Article 680.20 requires all branch circuits feeding pool equipment to be protected by a GFCI. The question is whether the AC panel itself must be GFCI protected. There are several options for providing GFCI protection for the AC panel. Firstly, a 50 amp GFCI breaker in the main panel. Replace the inverse time breaker with a GFCI breaker in the main 200 amp panel. This would provide GFCI protection for the entire feeder circuit to the AC panel. Secondly, a 50 amp GFCI disconnect. Install a GFCI disconnect switch at the disconnect location adjacent to the AC panel. This would provide GFCI protection for the AC panel and its branch circuits. Thirdly, a 50 amp GFCI outlet. Install a GFCI receptacle at the AC panel and plug the feeder into the GFCI outlet. This would provide GFCI protection for the AC panel and its branch circuits. The best option is to use a 50 amp GFCI breaker in the main panel. This provides the most comprehensive GFCI protection for the feeder circuit and all branch circuits, ensuring the safety of the pool equipment and users. The disconnect switch should be located within sight of the AC panel as required by Article 680.26. It should not have inherent overcurrent protection, but it can be interlocked with the AC panel breaker to prevent the breaker from being turned on without the disconnect switch being turned on first. To ensure compliance with Article 680 and provide the best protection for the pool equipment and users, install a 50 amp GFCI breaker in the main panel. The disconnect switch should be located within sight of the AC panel and should not have inherent overcurrent protection. It's crucial to understand the requirements of Article 680 of the National Electrical Code, particularly regarding swimming pools. This article outlines specific safety measures to prevent electrical hazards around pools. When dealing with electrical installations near pools, the primary concern is to minimize the risk of electric shock. This is achieved through a combination of grounding, bonding, and ground fault circuit interrupter, or GFCI protection. Article 680.20 specifically addresses the need for GFCI protection for branch circuits supplying pool equipment. While it mandates GFCI protection for these branch circuits, it doesn't explicitly state that the AC panel itself needs to be GFCI protected. This ambiguity leads to the question of how best to ensure comprehensive safety. Let's explore the various options for providing GFCI protection. The first option involves installing a 50 amp GFCI breaker in the main 200 amp panel. This entails replacing the existing inverse time breaker with a GFCI breaker. The primary advantage of this approach is that it provides GFCI protection for the entire feeder circuit that supplies power to the AC panel. This means that any ground fault occurring along the feeder cable or within the AC panel itself will be detected and the circuit will be immediately de-energized, thereby minimizing the risk of electric shock. The second option involves installing a 50 amp GFCI disconnect switch at the location adjacent to the AC panel. This disconnect switch would not only serve as a means to disconnect power to the AC panel for maintenance or emergency purposes, but it would also provide GFCI protection. This option is particularly attractive because it provides GFCI protection at the point of use, directly safeguarding the AC panel and its branch circuits. However, it's important to ensure that the GFCI disconnect switch is properly rated for the application and that it meets all applicable safety standards. The third option involves installing a GFCI receptacle at the AC panel and plugging the feeder into the GFCI outlet. This approach is similar to using a GFCI disconnect switch, but it utilizes a receptacle instead of a switch. While this option may seem convenient, it's crucial to ensure that the GFCI receptacle is properly rated for the amperage and voltage requirements of the feeder circuit. Additionally, the receptacle must be installed in a weatherproof enclosure to protect it from the elements, as the pool equipment is located outdoors. Considering all the available options, the recommended approach is to install a 50 amp GFCI breaker in the main panel. This option provides the most comprehensive GFCI protection for the feeder circuit and all branch circuits connected to the AC panel. By protecting the entire feeder, any ground fault occurring anywhere along the circuit will be promptly detected and de-energized, ensuring the safety of both the pool equipment and the people using the pool. In addition to GFCI protection, it's also essential to ensure that the disconnect switch is properly installed and located. According to Article 680.26, A. The disconnect switch must be located within sight of the AC panel. This requirement is intended to allow for quick and easy disconnection of power to the pool equipment in case of an emergency. The disconnect switch should not have inherent overcurrent protection, as its primary function is to serve as a means of disconnecting power, not to protect against overloads or short circuits. However, the disconnect switch can be interlocked with the AC panel breaker to prevent the breaker from being turned on without the disconnect switch being turned on first. This interlock provides an additional layer of safety by ensuring that the pool equipment cannot be energized accidentally during maintenance or repairs. In conclusion, to ensure compliance with Article 680 and to provide the best possible protection for the pool equipment and users, it's recommended to install a 50 amp GFCI breaker in the main panel. This approach provides comprehensive GFCI protection for the entire feeder circuit and all branch circuits. Additionally, the disconnect switch should be located within sight of the AC panel and should not have inherent overcurrent protection. By following these guidelines, can create a safe and reliable electrical system for the pool equipment. Always consult with a qualified electrician to ensure that all electrical work is performed in accordance with applicable codes and regulations. Furthermore, regular inspections and maintenance of the electrical system are essential to identify and address any potential hazards before they can cause harm. Remember that electricity and water can be a dangerous combination, so it's always better to err on the side of caution when it comes to electrical safety around swimming pools. Let's delve a bit deeper into the technical aspects of GFCI protection and its importance in pool environments. A ground fault circuit interrupter, or GFCI, is a device designed to protect people from electrical shock. It works by monitoring the current flowing through a circuit and comparing it to the current returning. If there is a difference of even a few milliamperes, which indicates that current is leaking to ground, the GFCI will trip and quickly shut off the power to the circuit. This rapid response is crucial in preventing serious injury or even death from electric shock. In the context of swimming pools, GFCI protection is particularly important due to the presence of water, which is an excellent conductor of electricity. Any electrical fault that occurs near the pool can create a dangerous situation, as the water can become energized, posing a significant risk to anyone in or around the pool. By installing GFCI protection on all branch circuits supplying pool equipment, the risk of electric shock is greatly reduced. If a ground fault occurs, the GFCI will trip and energize the circuit before anyone can come into contact with the energized water. When selecting a GFCI breaker for the main panel, it's essential to choose one that is properly rated for the amperage and voltage requirements of the feeder circuits. A 50 amp GFCI breaker is typically suitable for a 50 amp feeder circuit. It's also important to ensure that the GFCI breaker is compatible with the panel in which it will be installed. Different manufacturers use different designs, so it's crucial to select a breaker that is specifically designed for the panel being used. In addition to selecting the right GFCI breaker, it's also important to install it correctly. The GFCI breaker should be installed in accordance with the manufacturer's instructions and all applicable electrical codes. Proper wiring and grounding are essential to ensure that the GFCI breaker functions correctly and provides the intended level of protection. After installation, the GFCI breaker should be tested regularly to verify that it is working properly. Most GFCI breakers have a test button that can be used to simulate a ground fault and verify that the breaker trips. It's recommended to test the GFCI breaker at least once a month, or more frequently if there are any concerns about its performance. If the GFCI breaker fails to trip when tested, it should be replaced immediately. The disconnect switch plays a crucial role in the overall safety of the pool electrical system. As mentioned earlier, the disconnect switch must be located within sight of the AC panel, allowing for quick and easy disconnection of power in case of an emergency. The disconnect switch should be readily accessible and clearly labeled so that anyone can quickly locate it and operate it if necessary. The disconnect switch should not have inherent overcurrent protection, as its primary function is to serve as a means of disconnecting power, not to protect against overloads or short circuits. Overcurrent protection is typically provided by the breakers in the main panel. However, the disconnect switch can be interlocked with the AC panel breaker to prevent the breaker from being turned on without the disconnect switch being turned on first. This interlock provides an additional layer of safety by ensuring that the pool equipment cannot be energized accidentally during maintenance or repairs. When selecting a disconnect switch, it's important to choose one that is properly rated for the voltage and amperage requirements of the pool equipment. The disconnect switch should also be suitable for outdoor use and be enclosed in a weatherproof enclosure to protect it from the elements. Regular inspections of the disconnect switch are essential to ensure that it is in good working condition. The switch should be checked for any signs of damage, such as cracks or corrosion, and it should be operated periodically to ensure that it functions smoothly. Any problems with the disconnect switch should be addressed promptly to prevent potential safety hazards. Let's talk about bonding and grounding, which are also crucial for electrical safety around swimming pools. Bonding is the process of connecting all metal parts of the pool structure and equipment together to create a continuous electrical path. This includes the pool reinforcing steel, the metal pool walls, the metal ladder, the metal diving board supports, and any metal equipment associated with the pool, such as pumps, filters, and heaters. The purpose of bonding is to minimize the voltage difference between these metal parts. If a ground fault occurs, the bonding system will help to equalize the voltage, reducing the risk of electric shock to anyone who comes into contact with the metal parts. Grounding is the process of connecting the bonding system to the earth, typically through a grounding electrode system consisting of ground rods or ground plates. The purpose of grounding is to provide a low impedance path for fault current to flow back to the source, allowing the overcurrent protection devices, such as breakers or fuses, to trip and energize the circuit. Proper bonding and grounding are essential for the effective operation of GFCI protection. Without proper bonding and grounding, the GFCI may not be able to detect a ground fault, and the risk of electric shock will be significantly increased. The National Electrical Code, specifically Article 680, provides detailed requirements for bonding and grounding swimming pools. It's essential to follow these requirements carefully to ensure that the pool electrical system is safe and compliant. Regular inspections of the bonding and grounding system are essential to ensure that it is in good working condition. The connections should be checked for tightness and corrosion, and the grounding electrodes should be inspected to ensure that they are properly installed and maintained. Any problems with the bonding and grounding system should be addressed promptly to prevent potential safety hazards. Now, let's address the specific scenario of powering the new 50 amp panel from the existing 200 amp panel board in the dwelling basement. When tapping into an existing panel, it's crucial to ensure that the existing panel has sufficient capacity to handle the additional load. A load calculation should be performed to determine the total load on the existing panel, including the new pool equipment load. If the load calculation indicates that the existing panel is overloaded, it may be necessary to upgrade the panel or install a separate panel to supply the pool equipment. The feeder for the new 50 amp panel should be sized according to the National Electrical Code requirements. The size of the feeder conductors will depend on the ampacity of the breaker protecting the feeder and the type of conductor being used. It's important to consult the appropriate tables in the NEC to determine the correct conductor size. The feeder should be installed in a conduit or cable assembly that is suitable for underground burial. The burial depth should comply with the NEC requirements for underground wiring. The feeder should be protected from physical damage, and it should be installed in a way that minimizes the risk of moisture intrusion. As previously mentioned, the branch circuits supplying the pool motors should be protected by GFCI breakers. The GFCI breakers should be installed in the new 50 amp panel. The size of the GFCI breakers will depend on the ampacity of the motor circuits. It's important to consult the motor nameplate to determine the full load amperage of the motors and to select the appropriate breaker size. The pool motor should be bonded to the ground grid for the pool. This bonding helps to equalize the voltage between the motors and the pool structure, reducing the risk of electric shock. The bonding conductors should be sized according to the NEC requirements. The pool equipment should be located at least 16 feet from the inside wall of the pool, unless it is separated from the pool by a fence, wall, or other permanent barrier. This separation helps to prevent accidental contact with the pool equipment and reduces the risk of electric shock. Finally, it's important to remember that electrical work around swimming pools can be dangerous and should only be performed by qualified electricians who are familiar with the NEC requirements. Always obtain the necessary permits and inspections before starting any electrical work, and always follow all applicable safety precautions. Here are some additional points to consider regarding electrical safety around swimming pools. Firstly, never use extension cords to power pool equipment. Extension cords are not designed for outdoor use and can be easily damaged, creating a serious electrical hazard. Secondly, keep all electrical equipment and cords away from the pool edge. Never allow electrical equipment to come into contact with the water. Thirdly, regularly inspect all electrical equipment and cords for damage. Replace any damaged equipment or cords immediately. Fourthly, if you experience any tingling sensation while in or around the pool, immediately exit the pool and turn off the power to the pool equipment. Contact a qualified electrician to inspect the electrical system. Fifthly, if you are planning to install a new swimming pool or make any changes to the existing pool electrical system, consult with a qualified electrician to ensure that the work is performed safely and in accordance with all applicable codes and regulations. By following these safety guidelines can help to prevent electrical accidents and ensure that swimming pool is a safe and enjoyable place for everyone. Let's discuss the importance of proper documentation and labeling for the pool electrical system. Accurate documentation of the electrical system is essential for future maintenance and troubleshooting. The documentation should include a wiring diagram showing the location of all electrical components, the size and type of conductors used, and the ratings of all breakers and disconnects. The documentation should also include a list of all equipment connected to the electrical system, including the make, model, and serial number of each item. The documentation should be kept in a safe and accessible location, such as a weatherproof enclosure near the pool equipment. Proper labeling of the electrical system is also essential for safety. All breakers and disconnects should be clearly labeled to indicate the equipment that they control. The label should be durable and weather resistant, and they should be securely attached to the electrical components. The label should be easy to read and understand, even in low light conditions. In addition to labeling the breakers and disconnects, it's also important to label the pool equipment itself. Each piece of equipment should be labeled with its voltage, amperage, and horsepower ratings. The label should also indicate whether the equipment requires GFCI protection. Clear and accurate labeling helps to prevent confusion and ensures that the electrical system is operated safely. Finally, let's emphasize the importance of ongoing education and training for anyone who works on or around pool electrical systems. Electrical codes and regulations are constantly evolving, so it's essential to stay up to date on the latest requirements. There are many resources available for electricians and other professionals who work on pool electrical systems, including continuing education courses, industry publications, and online forums. By investing in ongoing education and training, can ensure that are equipped with the knowledge and skills necessary to perform electrical work safely and effectively. In addition to formal education and training, it's also important to learn from experience. Every electrical installation is unique, and there are always new challenges and lessons to be learned. By sharing experiences with other professionals and by carefully documenting work, can build a wealth of knowledge that will help to improve electrical safety and performance. Remember that electrical safety is everyone's responsibility. By following the guidelines and by taking the necessary precautions can help to prevent electrical accidents and ensure that swimming pool is a safe and enjoyable place for everyone. To recap, firstly, ensure comprehensive GFCI protection by installing a 50 amp GFCI breaker in the main panel. Secondly, position the disconnect switch within sight of the AC panel free from overcurrent protection, but optionally interlocked. Thirdly, prioritize proper bonding and grounding, adhering strictly to NEC Article 680. Fourthly, verify the existing panel's capacity with a load calculation before tapping into it. Fifthly, size the feeder appropriately, complying with NEC guidelines for underground burial. Sixthly, protect branch circuits with GFCI breakers in the new panel, matching motor amperage. Seventhly, bond pool motors to the ground grid, equalizing voltage. Eighthly, maintain a safe distance between equipment and the pool, adhering to the 16-foot rule. Ninthly, document and label electrical systems meticulously for safety and maintenance. Tenthly, continuously educate and train on the evolving electrical codes and safety practices.